explaining the solutions to the Math Kangaroo 2018 levels 7 through 8. Problem number 1. What is the value of 20 plus 18 divided by 20 minus 18? So to solve this, I just rewrote the equation, and you solve what's in the parentheses first because PEMDAS. And then if you solve what's in the parentheses first, then you go on to division. So parentheses and then division. So what's in the parentheses is 38 divided by 2, and that equals to 19, which gives us the answer of letter B. Problem number 2 says, when the letters of the word mama are written vertically above one another, the word has a vertical line of symmetry. Which of these words also has a vertical line of symmetry when written in the same way? So first of all you basically have to do is just draw a line through each. Or just identify the first letter. So the first letter R doesn't work because R does not have a line of symmetry. So A is out. The letter B doesn't have a line of symmetry either, so B and C are out. And then the letter D doesn't have a line of symmetry, so letter D is out, but the letter T does. So that means the answer is letter E. Problem number 3 says, a triangle has sides of length 6, 10, and 11. An equilateral triangle has the same perimeter. What is the length of each side of the equilateral triangle? So we know in an equilateral triangle, all 3 sides are the same. So let's first add up and find what the perimeter of this triangle is. So 6 plus 10 plus 11 equals 27. Now if we're doing the perimeter of an equilateral triangle, we have to divide this by 3 because there are 3 equal sides. So let's say x is the length of each side. 3x equals 27. So x equals to 9. So each side of the equilateral triangle has a length of 9, which gives us the answer of letter B. Problem number 4 states, which number should replace the star in the equation 2 times 18 times 14 equals 6 times star times 7? So in order to solve this, you should first divide these numbers into their factors. So then we would have 2 times 18's factors are 6 and 3. So 2 times 6 times 3, and then there's 14, which is 7 times 2. So times 7 times 2 equals to 6 times the star times 7. So in order to solve this, what you would do is you could just divide like similar factors from both sides. So you can take out the 6 and the 7. And now we're left with 2 times 3 times 2 equals 2 star. And that means that 2 times 3 is 6, times 2 is 12. So star equals to 12. And that would be our answer of letter D. Problem number 5 says, the panels of Fergus's fence are full of holes. One morning, one of the panels fell and flat on the floor. Which of the following could Fergus see as he approaches his fence? So in order to solve this, we have the drawing of the fence here. And when the fence falls down, you basically reflect it across. So in order to do that, let's just first reflect all of its contents across. So if we're reflecting this across, this triangle would now become an upside down triangle. So it would be like this. This upside down triangle would become a normal triangle. And then so on as this progresses. Okay, and now we have to deal with the circles. So if you notice the location of the circles, it's somewhere around the middle, but on the upper middle. So let's say this is the middle here, right? Let's see this line is the middle. So it's in the upper middle. So we reflect it down to the lower area. So 1, 2, 3, 4, 5. So now it's in the lower area. And now we just compare this with all the different pictures given on the problem. Given on the problem packet. And it matches the picture of letter C. So letter C is our answer. Problem number 6 says, Bertie the builder is assembling stairs. Each step is 15 centimeters tall and 15 centimeters deep, as shown in the diagram. How many steps does he need in the stairs in order to reach the second floor, which is 3 meters above the first floor in the building? So to solve this, we know that each step looks like this. 15 centimeters by 15 centimeters. There are a total of 100 centimeters per 1 meter. So now that we know this, let's assume that this is like the full slope. So we need to find what this is. So we could use Pythagorean theorem. So we do 15 squared plus 15 squared equals, let's say this is c squared. And we end up with c equals 15 rad 2. And now we have to figure out how large the rest of this is. So we know that that this is actually 300 centimeters high, because 300 centimeters equals to 3 meters. So now that we know that, we can figure out the rest of it. So we know that 300 centimeters squared plus 300 centimeters squared equals to c squared. And this, we'll label this as d squared. And that's because if we have this amount, we have 300, this has to be 300, and this has to be 300, because this has to be part of a square, since this is 15, 15. These two values have to be equal. So now we're trying to find what this length is. And this length is d. So with this, we get d equals to 300 rad 2. So now that we have that, we just divide these two. We have to find out how much of c goes into d. How many of this length goes into this whole length. So we do 300 rad 2 divided by 15 rad 2. The rad 2 cancels out, and then 300 over 15 is equal to 20. So in turn, it's just 20 over 1. And basically, that means that it takes 20 stairs in order to reach the second floor of the building. So our answer is D, 20. Problem number 7 says, a game consists of dropping a ball from the top of the board with rows of pins as shown in the picture. The ball bounces either to the right or to the left each time it hits a pin. One possible route for the ball to take is shown below. How many different routes can a ball take to reach bin B? So I didn't put down the route because we're going to figure out each one. So let's work our way from bottom to the top. So the only way that you can get to bin B is through these two bottom pins. So that leaves two possibilities at the bottom. Now if we look over here, if the ball falls this way, then it can let's first start off with a scenario if the ball falls to the right. So this is the left and this is the right. So the ball falls to the right, it goes like this, then it can fall to the left, and to the left, and then it falls in. So that's one method. Then let's see if the ball falls to the left here, but then it goes to the right here. But that's not possible because then the ball is never going to end up in bin B. So that's one method. Now let's see, now that's all the methods that we can do for if the ball goes to the right. Now let's see if the ball goes to the left. If the ball goes to the left, it can go to the left again, to the left, and then to the right. So that's another method. And then let's see if the ball goes to the left again. Now it can go to the right, and then it can go to the left, and then it can go to the left. That's a third method. So now we've covered on whether for this dot the ball can go to the left or right. So now that we've covered that, let's say the ball goes here, right? And then it goes to maybe the left here, and then maybe it goes to the left, but then it goes to the right here, and then it goes over, and that's another method. And then we could try the same thing with the other method. So we can go here, directly across here, but if we were to try and switch over, it would be the exact same method as the one we've done before. So therefore, if we look that there are only 4 possible methods left. That's the number of tally marks. So our answer is letter C, 4. Problem number 8 says, a large rectangle is made up of 9 identical rectangles whose longest sides are each 10 centimeters long. What is the perimeter of the large rectangle? Okay, so in order to solve this, we know that the longest side is 10 centimeters long. So that means that L equals to 10 centimeters when we're talking about the smaller rectangles. This is for the smaller rectangles. So how do we find the width? The width is this shorter distance over here. The way we find that is compare this. So 5 of these widths is equal to 2 of these lengths. So 5 widths equals to 2 lengths. Length is 10, so 5W equals to 20. So W equals 4. So the width each equals 4. So now it's asking for the perimeter. So we just substitute in the values. So we have 4, 4, 4, 4, 10, 10, 10, 10, 10, and 10. So now we just add together the sides. So this side has 4 plus 10 plus 4, which is 18. And then the other side has 20, 10 plus 10. So 20 plus 20, that's these two sides, is 40. 40 plus 18 is 40 plus 36, which gives us the answer of 76 centimeters as our ending perimeter. So that gives us the answer of letter C. Problem number 9 says, the diagram shows a rectangle with dimensions 11 by 7 containing 2 circles. Each circle touches 3 of the sides of the rectangle. What is the distance between the centers of the 2 circles? So to solve this, we have to first use the number 7. So 7 is the length of this side, which means that the diameter of these circles is 7. So the diameter is 7. We know that 2r equals the diameter. So the radius is 3.5. Now how can we use this? Well, if we have 3.5 over here, we can see that this is 3.5 and this is 3.5. And the distance between the 2 circles is this area, which we'll refer to as x. And this whole thing is equal to 11. So now all we have to do is 3.5 plus 3.5 plus x is equal to 11, which is basically 7 plus x equals to 11. And from that, we can get that x equals to 4. So the distance between the 2 centers of the 2 circles is 4, which gives us the answer of letter D. Problem number 10 says, square ABCD has sides with lengths equal to 3 centimeters. The points M and N lie on AD and AB so that CM and CN split the square into 3 pieces of the same area. What is the length of DM? So this is the length that we're looking for. So let's refer to the length of DM as x. So if we see that the areas of these 3 triangles are supposed to be equal, and since each side is 3 centimeters, the total area of this square is 9 centimeters squared, which means each of these triangles has an area of 3. Now let's focus on this particular triangle because it includes the side DM or x. So we know that the equation for a triangle is 1/2 base times height. So in this case, our base is 3 because each side is 3. But we don't know what our height is. Our height is x, but we know that the area is equal to 3. So 1/2 times 3 times height equals to 3, which goes to 3 over 2 h, or I'll refer to this as x instead to make it more easily understandable, equals 3. So if we divide both sides by 3 over 2, we get x equals to 6. And that is true for x equals to 2. X equals to 2, which is true because if we check x equals to 2, we have this. And also this is the right triangle, so 2 times 3, which is 6 divided by 2, would equal to 3. So our answer is correct. So the correct answer is D, 2 centimeters. Problem number 11 says, Martha multiplied 2 two-digit numbers correctly on a piece of paper. Then she scribbled out 3 digits as shown. What is the sum of the 3 digits that she scribbled out? So to solve this, let's put this in the normal way that we would solve this, with the scribbles as boxes, empty boxes instead. So we have this, then we have our numbers over here, and then we have a 0 over here, because when you put down the second part of double-digit multiplication, you have a 0 over here. Then we have 3, box 2. So we can't confirm that all the boxes are the same value. So we just base it off of logic. So this number has to be a 2. And the only number that multiplies with 3 and ends up with a units digit of 2 is 4. So we would have a 2 over here and carry over the 1. So from here, it's kind of a little bit of guess and check. So now let's move on to the second row over here. So now we have a 6. And then we have to have the number here that makes it go to a 3. So let's say we have the number 1. If we have the number 1, we would have a 4 plus the 1 that we carried over from the 12. And we would have 5. And that would be 11 over here. And then we'd have a 2 over here. So then we'd have this number, right? And then that would be equal to 312. And this perfectly works together. So now we just take the numbers in the boxes. That's 1, 4, and 1. So 1 plus 4 plus 1 equals to 6, which is our answer and gives us our answer of letter B. Problem number 12 says, a rectangle is divided into 40 identical squares. The rectangle contains more than one row of squares. Andrew found the middle row of squares and colored it in. How many squares did he not color? So in order to solve this, we all know that 40 has multiple different pairs of factors. So we can't do 40 in one because we can't have one row or just one column. So we have 20 and 2. We have 20 and 2, 8 and 5. And we also have 4 and 10. So the reason why we can eliminate 20 times 2 and 4 times 10 is because if we want a middle row, then one of the numbers has to be odd. Because with two even numbers, we can't have a certain middle row. So that will take away this pair and this pair. So we only have 8 times 5 left because 5 is an odd number. So now we have 5 by 8. And so now let's say this is the middle row and the middle row is all colored in. That means there are 4 other rows that haven't been colored in. 4 other rows by the 8 columns equals to 32. So our answer is 32 squares not colored, which is letter C. Problem number 13 says, Philip wants to know the weight of a book with a 0.5 gram precision. His weighing scales only weigh in 10 gram increments. What is the smallest number of identical copies of this book that Philip should weigh together to be able to do this? So in order to solve this, we just find out how many times 0.5 grams goes into 10 grams, because we have to be able to find how many copies and then divide that. So you would basically just do 0.5x equals to 10. And then your answer is x equals to 20. So you would need 20 copies of the book in order to be able to figure out the weight. And that means the answer is letter D. Problem number 14 says, a lion is hidden in one of the 3 rooms. A note on the door of room 1 reads, the lion is here. A note on the door of room 2 reads, the lion is not here. A note on the door of room 3 reads, 2 plus 3 equals to 2 times 3. Only one of these sentences is true. In which room is the lion hidden? Now, it's important to keep in mind that the room in which the lion is hidden doesn't have to be the room with the true sentence. So, first of all, we know definitely for sure that the note on room 3 is false because 2 plus 3 is not equal to 2 times 3. So, the note on room 3 is false, for sure. Now, let's try 2 scenarios. Let's say the lion was in room 1. So, if lion is in room 1, then room 1 would be true, but then room 2 would also be true, and only one note can be true, so it can't be in room 1. Let's say the lion is in room 2. If the lion is in room 2, then that means that the note on room 2 is false, and so is the note on room 1. So that means they would both be false. So the lion can't be in room 1. So that means the lion is in room 3. But a lot of people don't get this part, so let me explain it. If the lion is in room 3, that means that room 2's note is true. The lion is not here. And room 1's note is false. That means we have 2 false statements and 1 true statement. So the lion is in room 3. And that gives us our answer of letter C. Problem number 15 says, Valerie Yu draws a zigzag line inside a rectangle, creating angles of 10 degrees, 14 degrees, 33 degrees, and 26 degrees as shown. What is the measure of angle theta? So to solve this, before these marks aren't here, but actually these sides are right angles. So by doing that, we can actually just easily end up solving for theta. So we have to solve for these 2 angles, so we can subtract them from 180 to find what theta is. So first, let's start from the edge here. So we have 10 degrees and 90 degrees. 10 degrees plus 90 degrees is 100 degrees. 180 degrees, which is how many degrees there are in a triangle, minus 100 degrees is equal to 80 degrees. So over here we have 80 degrees. Now we go over to this side. So 26 degrees plus 90 degrees equals to 116 degrees. And 180 minus 116 degrees would be would be, I believe 64. So now we know that this is 64 degrees. So now that we have that, we can easily solve for this because these are straight angles. So that means that the sum of this angle, and this angle all has to equal to 180 degrees. So we do 180 minus 80, which is 100, then 100 minus 14, which is 86. 180 minus 86 is equal to 180 minus 86. Sorry. 100 minus 14 is equal to 86. Over here. And then we look over here. Now we have 33 and 64. So first of all, if we just do 100 minus 64 minus 33, we get the answer of 83. So now we just subtract these two angle measures from the total from 180 degrees, which is the number of degrees in a triangle. And we get 180 minus 86 minus 83 goes to 11. So theta is 11 degrees. So our answer is letter A, 11 degrees. Problem number 16 says, Alice wants to write down a list of prime numbers less than 100, using each of the digits 1, 2, 3, 4, and 5 exactly once, and using no other digits. Which prime number must be in her list? So first of all, let's start off with a little logic. So we have the digits 1, 2, 3, 4, and 5. Now we know that 4 can definitely not go in the units place because then we would have an even number, which is not a prime number. So 4 has to be in the tens place. Now 4 is in the tens place. In the units place, there can't be a 2 because then that would be an even number, and that's composite, not prime. So then, and there can't be a 5 because then it would also be a composite number because then there's the factors of 9 and 5. So it can only be 1 or 3. So now let's test out the different scenarios. Let's say if it was 43. If it was 43, we'd have the digits 1, 2, and 5 left. And with these digits, you cannot make two prime numbers because we could do 1 and 25. That doesn't work. And 1 is not considered prime nor composite. So we could also do you could try 51 and 2, but that wouldn't work because 51 is divisible by 3 because its digits add up to a number that is divisible by 3. So 45 does not work. So now let's try 41. If we did 41, we could have other combinations. You could do 53 and 2 or 23 and 5. Therefore, the number 41 must be there. And if we compare that to the list, we have letter D is 41, so our answer is letter D, 41. Problem number 17. A hotel on an island in the Caribbean advertises using the slogan, 350 days of sun every year. According to this ad, what is the smallest number of days Willie Byrne has to stay at the hotel in 2018 to be certain of having 2 consecutive days of sun? So in order to solve this problem, let's envision the worst case scenario. So let's say, the worst case scenario in this case would be if on his first day he has sun, second day no sun, third day sun, fourth day no sun, all the way until the end, which is and then so there are 365 days in a year, we're assuming, because 2016 is not a leap year. So that means we have 15 days that we could have rain. So let's imagine that is what happens. So let's say we have now we are 15 times later. So now we have 30. And we ended with the letter N. So that means we have to add on 2 days because now it has to be sun and there has to be another sun because there's no more rain, there's no more days of no sun left. Yeah, because there's no more days of no sun left. So that means that we just do 30 because 30 is 15 times 2 and there's 2 different outcomes each day. So 30 plus 2 equals to 32. So that means our answer is that Willie Byrne has to stay D, 32 days in order to be guaranteed 2 consecutive days of sun. Problem number 18 says, the diagram shows a rectangle and a line X parallel to its base. two points A and B lie on X inside the rectangle. The sum of the areas of the two shaded triangles is 10 centimeters. What is the area of the rectangle? So to solve this, we have these two rectangles. Let's pretend that there's a line going down here. So that means that we can just reflect this area over here. So, sorry. So that would mean that this has half of the square sticking out, half of the rectangle sticking out, half of the rectangle sticking out, and half of the other rectangle sticking out, square sticking out. So that means that this shaded area would have to be 1/2 of the total area. And since we know that these triangles, total area is 10 centimeters squared, if that's half of the total area, then that means that the total area is 20 centimeters squared. So our answer would be letter B. Problem number 19 states, James wrote a different integer from 1 to 9 in each cell of a 3x3 table. He calculated the sum of the integers in each of the rows and in each of the columns of the table. Five of his answers are 12, 13, 15, 16, and 17 in any order. What is his sixth answer? So let's first draw the table over here. So we have our 3x3 table. And don't automatically assume that just because 14 is not there, that it's 14. Because if you use your logic, you'll see that if we add up all the numbers and all from 1 to 9, 1 plus 2 all the way to plus 9, it equals to 45. Now that means that if we add up the numbers in the columns, it's 45. And if we add up the numbers in the rows, it's 45. So that gives us a total of 90. That means that all these numbers that we have so far plus the number that we don't know, which is 6th answer, which I'll refer to as X, all add up to equal to 90. So if we do that, we have 12 plus 13 plus 14 plus 15, plus 15 plus 16 plus 17 plus X all equals to 90. And this total gives us 73. So 73 plus X equals to 90. And that gives us an answer of X equals to 17. So our answer would be letter A, 17. Problem number 20 says, 11 points are marked from left to right on a straight line. The sum of all the distances between the first point and the other points is 2018. The sum of all the distances between the second point and the other points, including the first point, is 2,000. What is the distance between the first point and the second points? So in order to solve this, let's first label this area between the first and second point as X. So X is the distance between the first and the second point. So now we have distance between first and second. Okay. Now we have Y, which is the sum of distances from the second point all the way to the last point. So Y is equal to the distance between the second point to the third point, plus the distance between the second point to the fourth point, all the way till we get to the distance between the second point to the 11th point. And then now that we have that, let's analyze the blue section. The pink section represents Y, which is the second point. The blue section is the first point to all the other points. So if we can see here, from the first point to the second point is obviously X. First point to the third point is the same distance as the second point as the second point to the fourth point, because as you can see, it's over here and then the length is over here. So the distances are equal. So now that we know that, we realize that 10x plus y equals 2018. And you're wondering, well, why 10x? Well, we know that the distances of y already make up for all of this, because the distance between 2 to 3 is basically x. So we already have the distance of y, right? But y only covers until here, because this distance over here is equal to this distance over here. But we're not covering this very end distance, and that's where it's 10x's, because there's 10 gaps in between. So that's 10x plus in addition to the y. Now we have x plus y equals to 2,000, which we got from here because x plus y. We're still adding the x in the beginning. So now that we have that, all we have to do is just all we have to do is just subtract these equations from each other. So then we have 9x equals to 18. So x equals to 2. So what is the distance between the first and the second point? It is 2, which gives us the answer of letter B. Problem number 21 states, there are 3 candidates for one position as class president, and 130 students are voting. Suhaimi has 24 votes so far, while Kangaroo has 29 and Akmal has 37. How many more votes does Akmal need in order to be elected? So, in order for us to solve this, let's first create some equations. So let's do S as the amount of votes Suhaimi has. K is Kangaroo's and A is Akmal's. So S currently equals 24, K equals 29, and A equals 37. So far we have 90 votes in total, and there are overall in total a total of 130 votes. So 130 minus 90 is 40 votes. So 40 people have not voted yet. So now let's create 2 scenarios. Scenario 1 is where Suhaimi gets 0 added. Akmal gets plus x, which is an unknown amount. And then Kangaroo gets plus 40 minus x. So in this case, if we plug this in, 37 plus x would have to equal to 29 plus 40 minus x. Well, it has to be greater than that. And then we get the inequality of x is greater than 16. So x has to be at least 17. So x at least 17. Now we look at our second scenario, which is if S, Suhaimi, got added 40 minus x. So plus 40 minus x. Akmal got added x. And Kangaroo got added 0. So in this case, the inequality will be 37 plus x is greater than 24 plus 40 minus x. And we would end up with the inequality of x is greater than 13.5. So x will have to be at least 14. So now in this case, we take the greatest number, which is 17. So that means that in order for Akmal to be guaranteed a win, he must get 17 more votes, which gives us the answer of letter E. Problem number 22 says, the diagram shows a net of an unfolded rectangular box. What is the volume of the box? So in order to solve this, let's assign the values. Let's pretend that x is the length, y is the width, and then z is the height. So we know that the volume of a box is length times width times height. So basically our volume in this case is x times y times z. So now let's get on to our equations. So I labeled each side here. So 7 centimeters is z plus y, because this is z, this length is z, and this length is y. So 7 equals to, we'll do it this way, y plus z equals to 7. Now we have it up here as well. We have z plus x. So we have x plus z equals to 10 centimeters. And now 26. 26, we have x, y, we have x, y, x, y. So we have x plus y plus x plus y equals to 26, which is 2x plus 2y equals to 26. Now let's factor out the 2 to get x plus y equals 13. And now we can use a system of equations to subtract these equations from one another. So we get x minus y equals to 3. Now we combine these 2 equations in order to find our first part. So if we add these 2 equations, we end up getting the answer that x, If we add these 2 equations, we get that 2x equals to 16. So x is equal to 8. Now using x is equal to 8, we can find out all the other values. If x is equal to 8, we plug this in here. 8 plus z equals 10. Z is 2. If z is 2, we substitute that in here. Y plus 2 equals 7. So y equals 5. So now we have our x, y, and z. So we just multiply them all together. So then we get 8 times 2 times 5. And that's basically 8 times 10. So our answer is 80 centimeters cubed as the volume of the rectangular prism. So Our answer is letter C. Problem number 23 says, Ria wants to write a number in every cell on the border of a 6x5 table. In each cell, the number she writes is equal to the sum of the two numbers in the cells with which this cell shares an edge. Two of the numbers are given in the diagram. What number will she write in the cell marked X? So let's pretend that this value over here, is Y. So this value over here is Y. Over here, 10 plus something has to equal to Y. So 10 plus Y minus 10 equals to Y. Then over here, we have Y minus 10 equals to Y plus something, so negative 10. And then over here, we have Y minus 10 plus something is equal to negative 10. And that something would have to be negative Y. Negative Y plus Y minus 10 equals to negative 10. So now we have this, we know that negative 10 plus 3 is equal to negative Y. So negative 10 plus 3 is negative 7 equals to negative Y, so Y equals 7. Now if we substitute this in, over here we have negative 7. Over here we have negative 10, then we have 7 minus 10, which is negative 3. Then we have 7 over here. So 7 plus what equals to 10? 7 plus 3 equals to 10. Now 10 plus what equals to 7? 10 plus negative 7 equals to 3. And then 3 plus what equals to negative 7? 3 plus negative 10 equals to negative 7. Negative 7 plus what equals to negative 10? Negative 7 plus negative 3 equals to negative 10. Now we have negative 10 plus x equals to negative 3. And with this, we can determine that x equals to 7, giving us the answer of letter B. Problem number 24 states, Simon and Ian decide to have a race. Simon runs around the perimeter of the pool shown in the diagram while Ian swims the lengths of the pool. Simon runs 3 times faster than Ian swims. Ian swims 6 lengths of the pool in the same time Simon ran around the pool 5 times. How wide is the pool? So to solve this, let's use the equation of distance equals speed times time. If we convert this equation, we can get time equals to the distance over speed. So we know that it took the same amount of time for Simon and Ian to travel their lengths. So that means that for Ian's distance, so let's put di, Ian's distance is equal to 6 lengths of the pool, 6L. L is for lengths. And Simon's distance is equal to 5 times 2L plus 2W. W is width. So 2L plus 2W is the perimeter of the pool. And Simon ran around the pool 5 times. So 5 times the perimeter. And now let's do the speed. So for speed, we know that, that Simon is 3 times faster than Ian. So let's put S as, S is the speed. S is Ian's speed. So we know Ian's speed is just S. But that means, but Simon's speed and Ian's, based on the units of Ian's speed, is 3s. So now if we put this into an equation, we get the distance of Ian over Ian's speed is equal to Simon's distance over Simon's speed. Okay. So now that we know that, we can substitute this in. So Ian's distance is 6 times the length over S, because that is Ian's speed. And then we have Simon's equation, which is 5 times 2L plus 2W over 3S. So we can cross multiply. First of all, we can take out the S by multiplying both sides by S, so that the S's cancel out. So now that we have that, we just have 6L over 1 is equal to 10L plus 10W if you distribute it over 3S. Now if you cross multiply, we end up getting, so let's convert this 6L to its real value. So 6L would be 6 times 50, which is 300. So 300 times 3 is equal to 300 times 3, so this is 300 meters, times 3 is 900 meters, is equal to 10L, which 10L, if you multiply by 50, you get 500. So 500 meters plus 10W. And that means if we subtract 500 from both sides, 400 meters equals to 10W. So the width is equal to 40 meters if you divide both sides by 10. And that gives us our answer of 40 meters, which is letter B. Problem number 25 says, Frida's Flying Club designed a flag of a flying dove on graph paper as shown. The area of the dove is 192 centimeters squared. All parts of the perimeter of the dove are either parts of a circle or straight lines. What are the dimensions of the flag? So in order to solve this, we have to identify different parts. So this portion of the flag over here could easily be moved over here instead. And then this area could be moved over here. So that way in the end, the area of the flag would just be over here. So that means it would be 3x times 4x would be equal to 192 centimeters squared. So now that we have this, we could do 12x squared equals to 192. And 192 divided by 12 is 16. So x squared equals to 16. So x is equal to 4. Now the real dimensions of this are 4x by 6x. So 4x by 6x. So if we substitute in x equals 4, we get 16 by 24. And what answer does that give us? That gives us the answer of letter D, which is 24 by 16. Problem number 26 says, domino tiles are said to be arranged correctly if the number of dots at the ends that touch are the same. Paulius laid 6 dominoes in a line as shown in the diagram. He can make a move by either swapping the position of any 2 dominoes or by rotating 1 domino. What is the smallest number of moves he needs to make to arrange all the tiles correctly? So to solve this and make it easier for me, and probably for you guys too, I replace the dots with numbers, the number of dots. Okay. So what the real way to really solve this is just to identify what you need to do to bring the different elements together. So first, we're looking at this and we see that there's a 2 here, and there's also a 2 here. So we can match those up. So if we switch these two, we can match them up. So then we have 4, 6, 3, 1. And then instead of 4, 2, we have 6, 1, 3, 4, 4, 2, 2, 6. Now that we have this, we see, well, what other matches can we make? We see we have 2 3s here and a pair of 6 here. So we can switch these two. So we get 4, 6, 6, 1, 3, 1, 3, 4, 4, 2, and 2, 6. Keep in mind, this is our first move. This is our second move. So now what do we need to do in order for the different pairs to be matching? Well, it's really quite simple. We need to act on the 3, 1. If we flip it or rotate it, then the 1 is paired with the 1 and the 3 is paired with the 3. So we just switch this right around and we get 4, 6, 6, 1, 1, 3, 3, 4, 4, 2, 2, 6. Now if we look, 6 and 6, 1 and 1, 3 and 3, 4 and 4, and 2 and 2. So it matches, and this is our third move. So that means that there are a total of 3 moves that we make. So that gives us the answer of letter C. Problem number 27 states, points N, M, and L lie on the sides of the equilateral triangle ABC, such that NM is perpendicular to BC, ML is perpendicular to AB, and LN is perpendicular to AC, as shown in the diagram. The area of triangle ABC is 36. What is the area of triangle LMN? Oh, I forgot the C. Okay, so in order to solve this, we need to first identify a lot of the angles. So if this is a 90-degree angle, and this is an equilateral triangle, this is 60, 60, and 60. Now with this information, we see that we have a straight angle, so we have a 90 and 60. 90 plus 60 is 150, a straight angle is 180 degrees. So 150 minus this amount, which is 150 degrees, 180 minus 150 is 30 degrees. And then every triangle has 180 degrees, so that means this has to be 60 degrees. And so on. So the same process repeats over here. This is 30 degrees, and this is 60 degrees. This is 30 degrees, and this is 60 degrees. Now, as we can see, we have all of our angle measures. So, as we can see, these are 30, 60, 90 triangles. And with the 30, 60, 90 triangle, you have the hypotenuse equals to 2 times the shorter length, the shorter side, and then the longer side, LL, is equal to rad 3 times the shorter length. So let's assume that the shorter length is x. Now the shorter length is across from the smaller angle, so this is x. And then over here, because this is the hypotenuse, this is 2x, and then this length over here is x rad 3. Now with that knowledge, we know that each side of this equilateral triangle is worth x rad 3. But we need to find the area of this huge equilateral triangle. So this is 2x and this is x. Same thing here. X, 2x, x, 2x. So now we can see that each side of the larger equilateral triangle is 3x. The equation for the area of an equilateral triangle is a squared times rad 3 over 4. A is the length of one of the 3 congruent sides. So we can just substitute A with 3x, because x plus 2x is 3x. So then we get 3x squared rad 3 is over 4. And this is supposed to equal to 36. Now if we just take out 1/3 from this, you can just do 1/3. Wait, sorry, not 1/3. And now we have basically 9x squared. So 9x squared rad 3 over 4. So with this knowledge, this equals 36. We can further solve this answer. So as we can see, let's divide both sides by 3. So in that case, we're dividing this by 3. So then we have 3x squared rad 3 over you multiply both sides. No, you divide both sides by 1/3. Sorry. Okay. So now that we have that, we saw this over 4. Now if you notice, 3x squared is basically x rad 3 squared. And what is the value of x rad 3? X rad 3 is the value of each side in the smaller equilateral triangle. Which means that over here, we would have the equation of, basically, if you convert 3x squared to x rad 3 squared, you would have x rad 3 squared times rad 3 over 4 equals to 12. Now, as you can see here, that means that since 12 is 1/3 of 36, and this is the exact same equation we would be using if we were calculating for the area of the smaller equilateral triangle, that means the smaller equilateral triangle is 3 times smaller than the larger equilateral triangle. So now it's asking for the area of triangle LMN. And that, since it's 3 times smaller, it is 12. And that gives us our answer of letter B. Problem number 28 says, Azmi, Burhan, and Chu went shopping. Burhan spent only 15% of what Chu spent. However, Azmi spent 60% more than Chu. Together they spent $55. How many dollars did Azmi spend? So to solve this, let's first put Azmi, the amount of money Azmi spent is A. Yeah, Azmi is A, Burhan is B, and Chu is C. So we know that the amount of money Azmi, A, spent is equal to 1.6 of C, because he spent 60% more, which means he spent 160% of what Chu spent, and that is 1.6. And C is Chu's amount. Now we know what Burhan spent is 15% of what Chu spent. So that's 0.15 times C. Now using this equation, we can just do some substitution. So let's add these two equations together. So then we get A plus B is equal to 1.75 C. And if we substitute this in, because together they spent $55, so A plus B plus C is equal to $55. Now we can just substitute in this equation over here for the A plus B over here. So then we get 1.75 C plus C equals to $55. And with that amount, we know that 2.75C is equal to $55. And that means that C is equal to 20. Now we know that Chu spent $20. So with the amount of money that Chu spent, we can find how much money Asmi spent. Asmi spent 60% more than Chu, so he spent 1.6 times C. And we can just substitute in C here. And that means the amount of money that Asmi spent is 1.6 times 20, which is $32. Which means that Asmi spent $32, which gives us the answer of letter E. Problem number 29 says, Viola is practicing the long jump. The average distance she has jumped so far today is 3.80 meters. On her next jump, she jumped 3.99 meters, and her average increased to 3.81 meters. What distance must she jump with her next jump to increase her average to 3.82 meters? So, let's first solve this by understanding. So we do not know how many jumps she has done so far, but we know that 3.8 is the average so far times n. We'll pretend n is the number of jumps she's done so far, plus 3.99, the jump she just did, over n plus 1 is equal to 3.81. Now that we have that, we can convert this and multiply n plus 1 to both sides. So that way we have 3.8n plus 3.99 is equal to 3.81n plus 3.81. Now if we subtract 3.81 from both sides, we get 3.8n plus 0.18 is equal to 3.81n. If we subtract the 3.8n from both sides, we get 0.18 is equal to 0.01n. And that means if we calculate this, n equals 18. So she has done 18 jumps so far. So now that we have that, let's move on to the next part. So now we've calculated that n equals 18. So that means Viola has done 18 jumps so far. So now that we know that, we can go on to our next equation where we define x, which is x. X is the distance that she must jump in order to move her average up. So now we just do 3.81, which is her new average, times 19, because now she has done another jump, which is the 3.99, plus x, which we don't know, over 20, because now she's done 20 jumps. Including the x, this will be her 20th jump, is equal to 3.82. Now we just multiply 20 to both sides and we get 3.81 times 19 plus x is equal to 3.82 times 20. Now, you must use a calculator for this and be careful when you're doing calculations to not make any mistakes. Now this would end up being, if you calculated for these two values correctly, you would get 72.39 plus x is equal to 76.4. And if you subtract 72.39 from both sides, x, which is the distance that she needs to jump, is equal to 4.01. So our answer is 4.01 meters, which gives us the answer of letter C. Problem number 30 says, an isosceles triangle ABC, points K and L are marked on sides AB and BC, respectively, so that AK is equal to KL, which is equal to LB, and KB is equal to AC. What is the measure of angle ABC? So to solve this, let's first analyze the various parts. So if this length is equal, so if this two marked length is also equal to this two marked length, then since this isosceles triangles, this area has to be equal to this area. So this has 3 tick marks, so this is equal to this length. So now that we have that out of the way, let's mark this as angle X. Now all of us know that in an isosceles triangle, the angles that are opposite to the sides that are congruent are congruent. So these base angles are congruent. So this would also be X. Now as you can see, let's put a line between here, going from K to C. Now we've made this into 2 triangles, and these 2 triangles are congruent. Why? Because of the SSS postulate. which is when all three sides of a triangle are congruent, which makes the triangles congruent. So that means that because we have this side matching this side matching this side, and then the common side that they share, which means CPCTC. Corresponding parts of congruent triangles are congruent. So that means this angle x is equal to this angle x. So this part is also x. Now let's move on to this upper triangle. If this is x, this is the exterior angle of these two remote interior angles. So this would be x over 2, and this would be x over 2. So now we have all of the three basic angles in our triangle. That means x over 2 plus x equals to 180 degrees, because that's how many degrees are in a triangle. This ends up equaling to 2.5x is equal to 180 degrees, 180. And so if you saw this out, x equals to 72. But we're not done there, because we need to find out what angle ABC is, and angle ABC is x over 2. So we substitute in the value of x, which is 72, and we get 72 over 2, which is equal to 36 degrees. So the measure of angle ABC is 36 degrees, which gives us the answer of letter C.
Don't forget to subscribe and like. If you have any questions, you can email info@agoramathcircle.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email but without the info and the end. So bye!